So I will present this work, which is the name of the risk assessment of coastal ecosystems at the complex region of the Ria de Aveiro. I want to show you this picture. It was taken by a drone, and it shows very well the complexity of the Ria de Aveiro. In the right side, we have the Atlantic Ocean, and in the left side, we have the Ria de Aveiro. In this place, many activities are happening, and that's because the Ria de Aveiro is highly important in terms of culture and also of economy. Kind of activities are happening, like for instance, aquaculture, agriculture, tourism, bird watching. And the thing is that these human activities are posing a huge risk to the natural habitats of this place, and also to the way that these habitats can deliver ecosystem services. So the motivation of this work was to answer the questions of, for instance, which kind of habitats are most at risk and where? And also we wanted to know which human activities pose the greatest risk, and also how they influence the delivery of these ecosystem services. So to answer these questions, we applied the INVEST model, specifically the Habitat Risk Assessment tool. The inputs that this model needs is a map of the distribution of the habitats, also the spatial distribution of the stressors, which are the human activities, and also the effect of the stressors on habitats. And it is based on scientific literature and local knowledge. The way that it works is that the model has several criteria, the consequence criteria and exposure. For instance, we have the criteria like the change in area, the natural mortality, or the temporal overlap. We have to evaluate these criteria based on 3 different levels of risk. For instance, low risk can score with a value of 1, and high risk can with a value of 3. And then we can take these values and these models, the outputs in RGs. For instance, we can use RGs or QGs to see spatially the results of the model. And once we have the risk of these habitats, we can also do the second step of the model, which is to calculate the vulnerability. And then we take the risk of the previous step that was calculated, and it is multiplied by the availability of the ecosystem services per habitat to obtain this vulnerability. In our case, we were evaluating 5 different habitats: the sand flats, the salt marshes, mud flats, the seagrasses, and the bocage, which is basically land agriculture areas. And we are also evaluating 7 different stressors, which are tourism and recreation, the services, aquaculture, agriculture, the commercial development, environmental management. For instance, it includes the dredging activities, and in last step, the invasive species. So just to make you understand how it works, for instance, one example is that, for instance, we want to apply how will be the risk of seagrasses to the recreation. Recreations, for instance, are boats, the hand collecting, and we know that this has an impact in one of the criteria, which is the change of structure. For instance, increasing the turbidity can lead to a change in the structure of the habitats. So then we make the scoring. For instance, the boats that doesn't have any engine, we evaluate with a 1, which is the low risk. However, the boats that have an engine, we evaluate with the highest risk, a 3. And here I'll show you some results. For instance, this is the cumulative risk maps. We obtain this by per habitat. For instance, in the case of the mud flats, and in the right, in the case of the seagrasses, and we have the kilometers, the square kilometers of the area that is affected by the different activities. And also we have this per different subregions of the Ria de Aveiro. So for instance, in the case of the mud flats, in the main area, which is the biggest one, we have several different colors. The yellow, which is the one of the most that we can see. Also, the blue means the medium and the low risk. And in the case of the seagrasses, we can also see that there is also a smaller risk, but also because the seagrasses overlap less time and in less space with the activities. And also we have this kind of results, which is the risk plots. We obtain this per activities, per habitats, and then we have the 7 activities, and we can, for instance, in the case of the seagrasses, for instance, we can see that when we have an activity in the upper right of the graph, it means that there is the highest risk. For instance, in the case of the seagrasses, S4, which is environmental management, is the activity which is posing most risk. Okay, see, yeah, I will just finish with this, that this model is just very useful to prioritize locations for actions to reduce the risk, and also it's very useful to support marine spatial planning and ecosystem-based management. So, muito obrigada, y thank you very much.